Hello students, welcome you all once again. In the previous video, we have learned carbonyl compounds, what are aldehydes, what are ketones, their common names, IUPAC names, and some introduction about carbonyl compounds. In this video, we are going to learn about the isomerism shown by aldehydes and ketones. What is isomerism? Before going into details, let me tell you what isomerism is. Do you remember? You have learned isomerism, the types of isomerism, and also many examples under isomerism in your intermediate level. Okay, once again, I want to recollect the definition of isomerism. It is the phenomenon in which more than one compound have the same chemical formula but different chemical structures. That means the chemical compounds which possess identical chemical formulae but they differ in their properties and the arrangement of atoms in the molecule, they are called as isomers. Okay, and the phenomenon is called as isomerism. Okay, did you remember? It's the phenomenon in which more than one compound have the same chemical formula but different chemical structures. Coming to our carbonyl compounds, aldehydes show two types of isomerism. And also one more question I want to ask you here. How many types of isomerism are there? Or isomerism is classified into how many types? It is classified into two types, structural and stereoisomerism. Under structural isomerism, again, there are various types like chain, functional, positional, metamerism, etc. But aldehydes, they exhibit chain isomerism and functional isomerism. Coming to chain isomerism. What is chain isomerism? It is the phenomenon in which two or more compounds having same molecular formula but different arrangement of carbon atoms. The carbon atoms may be arranged either in straight chain or a branched chain. Such compounds are called as chain isomers and the phenomenon we call it as chain isomerism. Examples of chain isomers under aldehydes. See the example given here, CH3, CH2, CH2, CHO. It is named as butanol. Why? Because in this compound there are 4 carbons. The alkane having 4 carbons is called as butane. You know that at the end E is replaced by Al. Hence it got its name as butanol. And its chain isomer CH3CH CH3CHO. The main chain has 3 carbons. The alkane with 3 carbons is propane, and on the second carbon there is a CH3 group. It is called as methyl group. Okay, hence it is named as 2-methyl propanol. So if you observe the molecular formula of these two compounds, it will be same, but one is in a straight chain, the other one is in a branched structure. Hence these two are chain isomers. What is the second type of isomerism, students? It is functional isomerism. How do you define functional isomerism? I have given you the definition over here. Just look at it once. It is the phenomenon in which compounds having same molecular formula but different functional groups attached to them is called as functional isomerism. If you look at the example, it will be easy for you to understand. CH3, CH2, CHO. It is called as propanol. Why? Because it has only 3 carbons and hence it is called as propanol. Its functional isomer CH3, C double bond O, CH3. It is called as propanone. What is the difference between these two? It has aldehydic functional group. It has means propanol has aldehydic functional group, whereas propanone has ketonic functional group. Their molecular formula remains the same, but they possess or they contain different functional groups. Propanol has aldehydic group, propanone has ketonic functional group. Next, coming to ketones. Ketones show chain isomerism, functional isomerism, and also metamerism. Okay, so three types we can observe under ketones. Coming to chain isomerism, I am not giving the definition once again here because you have already learned under aldehydes. So just look at the examples given. 2-pentanone and 3-methyl 2-butanone. 2-pentanone is CH3, CH2, CH2, C double bond O, CH3 is 2-pentanone, CH3, CH, CH3, C double bond O, CH3 is 3-methyl 2-butanone. One has a straight chain and the second one has a branched chain structure. Okay, so difference in their structures and hence they are called as chain isomers, but their molecular formula remains the same. Next, functional isomerism, the same example given under aldehydes you can quote here. So need not write once again here. Next, the third type is metamerism. What is metamerism? This is the isomerism which occurs or which arises due to presence of different alkyl chains on each side of the functional group. Once again, it is the isomerism which arises due to the presence of different alkyl chains on each side of the functional group. Look at the example given. CH3, CH2, CH2, C double bond O, CH3. What is it called as? Try to name it. It is called as methyl propyl ketone. Because one side there is methyl group, the other side there is propyl group. Hence it is named as methyl propyl ketone. Next, its metamer CH3, CH2, C double bond O, CH2, CH3. On either side of C double bond O, there are two ethyl groups. Hence it is called as diethyl ketone. Both are almost same molecular formula, but the only difference is on either side of the functional group, there are different alkyl groups. Next, coming to aromatic aldehydes and ketones. These are of two types. What are the two types under aromatic aldehydes? Look at the first one. The compounds in which an aldehydic group. What is aldehydic group, students? C double bond O H, or together we can call it as CHO group is attached directly to an aromatic ring. Is attached directly to a benzene ring. Okay. So look at the structure of the aromatic aldehyde in which CHO is directly attached to aromatic ring. Do you know the name of this compound? I have written the name of this compound below the structure. It is called as benzaldehyde. What is the spelling, students? B-E-N-Z-A-L-D-E-H-Y-D-E. We can also write its formula as C6H5 C double bond O H or C6H5CHO. You can write its molecular formula. Okay. So it is the first type under aromatic aldehydes. Okay. These are the compounds in which CHO is directly attached to the benzene ring. Then what is the second type? The compounds in which CHO is present in the side chain. So the example given here is phenyl acetaldehyde. So you can write the formula as C6H5 CH2 CHO. Okay. So now CHO is not attached to the ring directly, it is present in the side chain, but it also comes under aromatic aldehydes. Okay, so I hope you understood the two types of aromatic aldehydes. Next, coming to aromatic ketones, the carbonyl group is present in between two aryl groups or one alkyl and one aryl group. Okay. What are aromatic ketone, students? The C double bond O group is present in between two aryl groups or one alkyl and one aryl group. Okay, don't make a mistake over here. Don't write carbonyl group is present in between two alkyl groups. It is not an aromatic ketone. It will be an aliphatic ketone. So while writing, be very careful. An aromatic ketone is the ketone in which the C double bond O group is present in between two aryl groups or one alkyl and one aryl group. Okay, the examples given here, benzophenone. What is the formula of benzophenone? C6H5, C double bond O, C6H5. So C double bond O is present in between two aryl groups. Okay, C6H5, C double bond O, C6H5. We can also call it as diphenyl ketone or benzophenone. Spelling BENZOPHENONE. Next example, acetophenone. So just observe here the difference between benzophenone and acetophenone. Have you noticed the difference? What is the difference? Here C double bond O is present in between one alkyl group, that is CH3, and one aryl group, that is C6H5. Okay, now what is the formula of acetophenone? C6H5, C double bond O, CH3. So practice the structures, the formula of all these compounds, so that even if you wake up in the middle of night, you should be able to remember all these structures. So try to love organic chemistry. It will be quite interesting. Fine. Okay. So in this video, we have learned isomerism, the aldehydes and ketones, showing different types of isomerism, and also aromatic aldehydes and aromatic ketones. Thank you.